hopefully everybody can hear this. This note is for people that are looking at a picture with no sound. Hopefully they'll be able to reset their computers or get it set up so they can hear this video. We are in chapter 2. This is the study guide, and this is chapter 2, section 1, part 2. And it's on testing conjectures and finding counterexamples. So when we test something, we're really questioning whether it's true or not. It doesn't seem to be quite right. And so sometimes, like for example, if I said, Mr. Thompson always wears a blue shirt, and he walked by the door and someone noticed that he was wearing a red shirt, you could say, no, see, he's wearing a red shirt. When you can find something that's opposite of a rule, that's called a counterexample. So, Mr. Thompson wearing a red shirt would be a counterexample to my statement that says that he always wears a blue shirt. So, basically, a counterexample is any one specific example that proves a statement is wrong. So, for example, if somebody said that a quotient, that means you're dividing two numbers, a quotient of any two whole numbers is always a whole number. Well, can you come up with the two numbers that if you divided them you wouldn't get a whole number answer? Sure. How about 3 divided by 8? That would be something that's not a whole number. In fact, it would be a decimal. You could leave it as a fraction, 3/8. Or it would be a decimal. 0.375. Either way, your answer is not a whole number, is it? So, coming up with this is called a counterexample. Any example you can think of that shows that the statement is wrong is a counterexample. Now the next one is a little confusing because you have to know what absolute value is and you have to know what difference is. Basically what they're saying is if you take the absolute value of a number and then subtract it with the absolute value of another number, your answer is always positive. So let's say we take the absolute value of these two numbers. If A is -5 and B is 6. When we take absolute value, we basically find the length of that number on a number line starting at 0. So if we go from 0 to -5 on a number line, we've traveled a distance of 5 units, so the absolute value of -5 is 5. If we travel from 0 to 6 on a number line, we've traveled 6 units. So the absolute value of 6 is 6. Okay, now what they're saying is when you subtract these two, your answer is always positive. Is that true? Is 5 minus 6 something positive? No, it's -1. So this would be a counterexample to the statement. You're showing that the statement is not always true. Sometimes we think that the quote-unquote smart kids in class always have the right answers. And, you know, we'll say, gosh, you just know all the answers. And you know what? I find that these types of students say, well, I didn't know number 10, or I didn't know, you know, the last example. And they're basically giving you a counterexample to your statement that they know everything. All 6-sided shapes are regular hexagons. Well, to be a hexagon, it has to have 6 sides. But to be a regular hexagon, it needs to be equilateral and equiangular, meaning that all the angles, and all the sides match each other. So, are all hexagons shapes that have all sides that match and all angles that match? That's what they're saying. Well, I think we can draw a counterexample here. If you draw a hexagon, 1, 2, 3, 4, 5, 6. There. There's a shape that has 6 sides. 1, 2, 3, 4, 5, 6. And the sides aren't equilateral, are they? We've got some short sides, some medium sides, some long sides. And are all the angles the same? Yeah, probably not. If we measure them, they'd be different in different places. So this is my counterexample to this statement, that all 6-sided shapes are regular hexagons. If we have a statement like the sum of 3 numbers is always odd. Okay. That means that when you add any 3 numbers together, the answer is an odd number. Well, what if I added 1 plus 9 plus 3? Well, that's 10, that's 13. Oh, that's not a counterexample, is it? Because that's showing what they're saying. We need to find something that shows that it's not always true. So let's change the first number to a 2. That would give us 14. Now we've added, that means sum means add. We've added all the 3 numbers together, and the answer is not odd. There we go. That is a counterexample to the statement. Because we've shown that the statement is not always true.